Hey everyone, Roger here from Ask the Car Experts YouTube channel, and today we're going to be using an oscilloscope from Gotchifix. I'm going to show you how to set it up and how to check the PT can and the K can on a BMW. Please remember to like and subscribe. Let's get into some electrical diagnosis. Now on a BMW X5 on the right hand side in this well, you're going to see this wiring loom. There's a cover right above it, and this is where you can access the PT can and the K can wiring. There's splices down in this well. Water can get in here, and sometimes they can cause corrosion on these connections and lead to an issue with both the K can, which is a carrossery or body can, or the PT can, which is the powertrain system. Using the oscilloscope from Gotchifix, we can actually use it to help diagnose the issue and actually see what's going on with both the PT can and the K can. Now, while this is a dual channel scope, we're going to start with just one channel. It starts in the voltage setup because this is also a digital volt ohm meter, so you can use that as well. We want to switch it to channel 1, which is going to be for our oscilloscope, and you can see that's the baseline right there. Each square will represent your voltage setting, so you can set it up to like 5 volts per increment or 1 volt per increment depending on the situation that you need. To set the scope up, you press up to change your voltage per increment. So you can see it went to 1 volt and 100 millivolts, and we're actually going to set it to 5 volts. And that's going to be for that. Now if I go over and press the right tab changes the time, so that's going to change to microseconds or milliseconds depending on what we need, and usually what works good for this is 20 microseconds. So I'm going to set that up right there. Now right now we don't see a signal because the car's asleep, but if I hit the lock or unlock button, I wake the car up, and you can see I have communication now. Let me show you what happens if you change the voltage setting. You can see me changing it right here, and it moves the voltage upwards, right, because I'm changing the increment. So what you can end up doing is moving it completely off the screen accidentally. So you want to make sure that you're using the correct voltage range, or else you won't be able to see the signal that you need. Now I have this set up with a dual scope, and I'm on the K can, which is this green wire right here, and I'm on the other side of the K can, which is K can high and low, and the two grounds. You can see that here's my signal. They overlap each other, and you can see the voltage ranges, and they should look like this. This means that the K can high and low are actually working correctly, but you can see them overlapping each other. Now if it was just a flat bar, that would be a short to ground, or if it was pulled all the way high like 12 volts, that would be a short to positive. This signal right here though would actually be a good signal, and you know that your communication is working. If you were checking out a module, you would need to check obviously that has power, ground, and bus communication, and this would show that the bus communication is good, and that would usually mean that the module is faulty. You can also separate the splice at certain locations and then monitor the signal to see if the issue is on a specific leg on a splice to a component. Now I'm connected to the PT can, which is this blue wire and the red wire. Right here, you just pull these sheathings back and you have access to the junction, and this is where you'd get corrosion if water did get down in this well. And we're going to take a look at what this looks like. You do need to have those good grounds on there. Now we're going to take a look at what the PT can signal or powertrain can signal looks like using channel 1 and channel 2. Now the PT can should be a mirror image of each other. You can see right there, that's the powertrain. That's a good signal. I have one set at 5 volts per division, and then channel 2 set at 200 millivolts to get a good signal. Now the powertrain system has the DME, which is the engine control unit, the junction boxes on there, the dynamic stability control, and the VTG, which is your transfer case module. Your EGS is your transmission, your GWS is your shifter, the EKPS, which is the fuel module, the EMF is your parking brake, and it's the red wire and the blue-red wire for the PT can. Now if the system can't communicate, usually it means that all of these modules will go down, and you'll have to diagnose it to verify that you have power, ground, and bus, and you have to disconnect each component one at a time in order to figure out where the issue is. And you can use obviously context clues. If something is spilled in the GWS or shifter area, obviously you'd want to check that first, unplug it, and see if the bus system comes back online. Now this unit is under $200, and even if you went for diagnosis at a shop, a lot of times the labor rate is above $200. So even you just investing $200 in the Gotchifix, it gives you a great tool to diagnose the bus systems, and you can also use it as a voltmeter. It is a 3-in-1 unit, so it has the oscilloscope, it has a waveform generator, and it is also a digital volt ohm meter. And with it being a 2-channel scope, you can actually see both high and low signals at the same time, so you can get a nice comparison. It also has a long battery life of over 10 hours after fully charged. I'm going to post a link with a discount code in the description box. If you're a home mechanic or even at a shop setting, this is a quick and easy tool to diagnose a communication issue.